Hi, in this video we are going to discuss the experiments to determine the equilibrium constant Kc of an esterification reaction. So I'm going to first talk about some background knowledge of how to work out the equilibrium constant as well as this reversible reaction, and then we will talk about some experimental procedures, and I will give you a demonstration and also tell you some things you have to pay attention to in order to have a successful experiment. So first of all, in this experiment, we are looking at an esterification reaction between propyl 1 and ethanol acid, forming propyl ethanoate and water. And this is a reversible reaction catalyzed by concentrated sulfuric acid, and it must undergo heating under reflux. Okay. Now, first of all, the equilibrium constant expression again is simply the product concentration at equilibrium over reactant concentration at equilibrium. So the idea, if you put it very simple, all we have to do in this experiment is to find out all four numbers here and plug it into the equation and finding out the Kc. Okay? Sounds easy. However, the reality is more complicated because how exactly are we going to carry out the experiment? How exactly are we finding out the concentration of these chemicals? In fact, you realize that it is quite difficult to find out the concentration of ester, concentration of water, concentration of alcohol directly from an experiment. In fact, what we're actually doing is to find out the concentration of ethanoic acid. And using the stoichiometry, using the relationship between the reactant and product, we are able to work out the rest of the concentrations. So in this experiment, we are focusing on the concentration of ethanoic acid. And we try to find out the concentration of acid using, of course, an acid-alkaline titration. So we are going to titrate the ethanoic acid in the mixture using standardized sodium hydroxide solution. Now, let's look at this table here, which is ICE table or RICE table, helping us out to work out the Kc. Okay? So first of all, in this experiment, we will start by using known amount of alcohol and ethanoic acid. Okay? So make sure you measure and you record the amount of alcohol and acid we used. Now, according to the manual, it says that we use equal amounts of ethanoic acid and alcohol. Now, in fact, in our experiment, we will perform 3 titrations in total. The purpose of the 3 titrations is to find out the initial concentration of ethanoic acid as well as the concentration of ethanoic acid at the equilibrium. But why do we need to have 3 titrations? I will explain it later. But all you have to know is, in our experiments, we are able to use titration to find out the initial concentration of ethanoic acid as well as the equilibrium concentration of ethanoic acid. Okay? Now, that means we are able to get the initial concentration of ethanoic acid. Let's just use A, okay, to represent the initial concentration of ethanoic acid. Okay? And like I said, we assume these two are the same. So if this is A, this is also A. Okay? And this one is obviously 0, 0. So we don't have ester and water at the beginning. Okay? Now just erase this one. A bit. Now, this part is changed. So during the reflux, obviously some of the reactant will react to form the product, right? So we can have minus y, and this one will be plus y, plus y. So because just that they are all in 1-to-1 mole ratio. Okay? So at the end, the equilibrium concentration, it is going to be A minus y, okay? And then over here will be obviously y and y, okay? If you're following this setting, okay? So if you plug all these numbers back to the equilibrium constant expression, then it's going to be Kc equals to these two multiplied together, so we got y squared over A minus y, okay, this one, okay, squared. Well, do we actually have to solve this equation? No. Actually, this one, we know this one. We experimentally determine this one. So we have this one, we have this one, then we can easily find out Y, which is the change in concentration of ethanol acid. So if we know Y, then we may as well know this, we may as well know this. And then, like I said, we assume these two are the same. So if we know this one, we also know this one. Okay? So you realize that actually we don't have to solve any equations or problems. Everything we can determine in an experiment, and we can later on, like I said, plug in all these numbers into the expression, then we can work out the KC. So this is the idea about this experiment. Okay, in this experiment, we can divide the procedures into 5 stages. So the first stage is we try to weigh our alcohol and acid using an electronic balance. The second stage is we are going to perform a titration to find out the initial concentration of ethanol acid. Now in this stage, we are going to use a 1 ml pipette to get 1 cm cube of the mixture of alcohol and acid, and then we perform a titration with that 1 ml portion. So in other words, we are trying to find out the concentration of ethanol acid in 1 ml of the mixture. Now, in the third stage, again, we will perform a titration. But this time, we will perform a titration after we add the concentrated sulfuric acid catalyst. Now, the idea is because you realize that both the ethanol acid and the concentrated sulfuric acid will be neutralized by the sodium hydroxide solution. So think about it, at the end, after we have done the esterification, when we are doing that titration to find out the equilibrium concentration of ethanol acid, in fact, some sodium hydroxide solution are used to neutralize the concentrated sulfuric acid catalyst. So that's why we need to first find out the volume of sodium hydroxide solution required to neutralize the concentrated sulfuric acid catalyst first before we actually carry out our reflux procedures. Okay? So here, that's why after we find out the initial concentration of ethanol acid, we need to add the corn sulfuric acid and immediately carry out another titration. Now, you should expect to see that in stage 3, in this titration, you should have to use more sodium hydroxide solution than you did in stage 2. So, in fact, the titer from this titration and this titration allow us to find out the volume of sodium hydroxide required to neutralize the concentrated sulfuric acid catalyst. So later on, this volume of sodium hydroxide can be used to correct or rectify our titration result in the later stage. Then we will actually heat our apparatus under reflux for at least 30 minutes. And after that, we will perform our third and the last titration to find out the equilibrium concentration of ethanol acid. And remember, like I said, in this stage, you need to correct the result using the volume used to neutralize the concentrated sulfuric acid. Okay, so that would be the outline or the overview of the experimental procedures. Let's move on to the actual steps, and I will guide you through one by one. So let's move on to the first stage. Okay, so during the first stage, we are going to weigh our sample. So we will have our pear-shaped flask with the stopper here, and we need a beaker to hold it. So in the electronic balance, we will put it inside. We will also put the stopper here. Okay. The reading over here is 121.742. Now, first of all, we will add our ethanol acid. This is a pure ethanol acid. Now, we need to have 0.25 moles of acid. So if you calculate the mole calculation, you realize that we will need around 15 grams. So because both acid and alcohol has a density of smaller than 1, so we will need a little bit more than 15 cm cube. So my suggestion is you first measure around 15 cm cube and you can pour it down. So we can pour it in around 15 cm cube. Well, that's a little bit too much, but again, you do not have to be very accurate. You just get approximate amount, and most importantly, you know the actual amount. Okay? Now, if you really want to have a very, you want to have the weighing very close to 0.25 moles or 15 grams, after you have added around 14 grams, you can use a dropper to finish off the remaining mass of alcohol. Okay, I think that should be okay. So make sure you put down the initial amount of the acid and alcohol. Now, after you have weighed your sample here, make sure you shake it thoroughly so that they are well mixed. And we are going to carry out a titration using this mixture before we add any sulfuric acid. So, first of all, you need to fill up your burette with the sodium hydroxide. Of course, you need to clean it first and make sure you clean it with the sodium hydroxide solution. And then we also need to fill up our clinical flask. Now, for clinical flask, we will first add around 25 ml of distilled water. And to that, we will add 1 drop of phenolphthalein. And then, this time we are going to use our 1 ml pipette. What we're trying to do is to get 1 ml of the mixture into the clinical flask for titration. Now pay attention, do not pour too much because we don't have a lot of mixture. Also pour a small proportion to clean the pipette. Now in fact, we only need altogether 3 ml of the mixture for the titration. So do not pour too much out, otherwise you may have not enough mixture. Now be careful when you use the 1 ml pipette, the liquid goes up very fast. Now for the micro pipette, it will be best if you take away the filler. So proceed to the titration. So once you see you get a relatively large area of pink in the content of conical flask, it would be best if you slow it down. Now you should expect to see the endpoint gives you a pink color. Alright, so now it hits the endpoint. Now, a tips for you, you can actually do some calculation before you carry out the titration in order to find out what is the approximate endpoint. Okay? Of course, you can also rely on the first trial, which is a rough trial. Now, after we have finished off the first set of titration, it is the time to add the concentrated sulfuric acid and then carry out the titration again. However, pay attention to one thing. Because once we add the concentrated sulfuric acid, the reaction may already start, and part of the ethanol acid may be consumed. Therefore, we must extract 1 ml portion of the mixture as soon as possible after we add the concentrated sulfuric acid. So in order to speed up the process, I will first add the 25 ml of water into the chemical flask first, as well as the indicator. Now, for the concentrated sulfuric acid, we must add it inside the film cupboard. We will have to add 8 drops of it. Now, again, once you have added the concentrated sulfuric acid, you should transfer the mixture as soon as possible into the conical flask. Otherwise, the reaction may already start. Part of the ethanol acid may have been consumed. Now, adding the mixture into the water will significantly dilute the concentrated sulfuric acid and therefore preventing the reaction from going too fast. So that's why we need to do this step as quick as possible if you want to get a more reliable result. Now we use a pipette, like I said, it would be best if you take away the pipette holder, otherwise the pipette will not be that great. Okay, so okay, and so this is what I get after the first 2 sets of titrations. So actually, these 2 values will give us the volume of sodium hydroxide requires to neutralize the concentrated sulfuric acid. After we get the average titer, which represents the equilibrium concentration of ethanol acid, then we should subtract 0.6 from the average titer of the 3rd titration. Okay, entering to the stage 4 where we actually carry out our reflux. Make sure you know how to construct a reflux setup. So first of all, we have the Bunsen burner, and we need to have a tripod and wire gauze, stand and clamp. So first of all, our pH flask here with our mixture, we will secure it onto the clamp. Remember, when you are holding the pH flask, you should be holding the neck of the pH flask, okay? So try to adjust it so that the pH flask is touching the wire gauze. Okay, so the next item would be the reflux condenser. So remember, the water should get in from the bottom and get out from the top. So water in, okay? Water in at the bottom. The water out here, this one. All you have to do is to put this one on top, like this. Okay? Now, and before we start our reflux, make sure you add the anti-pumping granules. Okay, light up the flame. And don't forget to open the water tap so that the condenser is having water flowing through. Now, as you are doing the reflux, try to pay attention to the condensation ring try to make sure the condensation ring is within the center of the reflux condenser. Now, if the heating is too vigorous, chances are the condensation ring may move to the top of the condenser, and this is not desirable because that means that some of the vapor may escape from the condenser. Now, if that takes place or you simply realize that the heating is too strong, try to remove the heat a little bit, adjust the air hole or the air supply so you can get a very consistent heating where the condensation ring is within the middle of the reflux condenser. Okay, after the mixture has been refluxed for some time, it is time to stop the heating. So we will close the air hole and then remove the heating. And we will let the setup to cool down in air for a few minutes before we actually transfer it. We can make the apparatus up a little bit. Now pay attention, some of you may try to remove the condenser and then put back the stopper. This is not a good idea because you will not be able to remove the stopper later because of the thermal contraction as the pear-shaped flask contracts as it cools down. So do not put this one back. Just let it stand here for a couple of minutes and then we will cool it off using an ice bath. Okay, once the content has been cooled off, we can prepare ourselves an ice water bath and we are going to cool it down in an ice water bath. And after the mixture has been cooled off, we can perform our last set of titration. This time you should expect to have a smaller titer